Hey everyone, today's lesson from Unit 3 is our last one. It's notes number 6 on CPCTC proofs. That's where, once we prove triangles congruent, we can say other parts are congruent according to CPCTC. Corresponding parts of congruent triangles are congruent. So, in short, you're going to be able to write CPCTC in your proofs. So once you prove triangles congruent, we get to use this. Now, in our example, it's a little bit unusual, okay? So another teacher made this particular example. It's unusual in that we have two letters at two of these vertices, okay? So it's just in this particular instance to help us kind of identify some things that are congruent to each other. What I noticed is that these triangles are back to back and they share this line segment. Right, so that would be congruent to itself. That would allow us to say that triangle ABC on the left is congruent to triangle OUS on the right by side, angle, side. Now, once you have a congruent statement like that, then we know that this means to us that, for instance, angle A in the first triangle is congruent to angle O. Angle B from the first triangle is congruent to angle U in the second triangle. And finally, angle C is congruent to angle S because they are corresponding parts of congruent triangles, so they're congruent. Right. Also, corresponding sides are congruent, so line segment AB from the first triangle would be congruent to OU. Line segment BC would be congruent to line segment US in the second triangle. And finally, line segment AC, first and last letter of this first triangle, would be congruent to line segment OS. Again, because they are corresponding parts of congruent triangles, so they're congruent. Okay, so now we're going to take a look at how this gets used in the proof. But I do have to tell you that there's one piece of missing information, and that is that line segment LM is congruent to line segment ON. Okay, so if you could just add that in there. All right, we're going to take one piece of given information at a time, because I see first up we are given that line segment LM is parallel to line segment ON. And like always, I'm going to extend those parallel lines just to make them a little bit more visual, okay? A little bit more important, I guess. So, first piece of given information is just that. LM is parallel to ON. Alright, we've seen parallel lines a lot. When two parallel lines are cut by a transversal, hopefully at this point you'll be able to tell me that alternate interior angles are congruent. So in line 2, we're going to name those alternate interior angles that I just marked. And they are angles MLN. And MLN is congruent to ONL. Make sure you use that angle symbol in there. And we're going to say they're congruent by the alternate interior angle theorem. Okay, so we've used up that piece of given information. Go to your next piece of given information, which is just a simple fact. Line segment LM, the top part of the picture, is congruent to line segment ON. So this side in the top triangle is congruent to this side in the bottom triangle. Okay, let's get that into our proof in line 3. Okay, line segment LM, congruent to line segment ON. And how do we know it? I gave it to you. Alright, so it's given information. Okay. Now we're out of given information. Obviously, there's nothing else on our list. We kind of checked off that we used both of those. So now we want to go to the picture. And what I notice is that this side that I highlighted earlier is shared by the two triangles. So that side is going to be congruent to itself by the reflexive property. So in line 4, we're going to go ahead and say that line segment LN is congruent to line segment LN by the reflexive property. All right, let's check and see how we did. In line 2, we proved a pair of angles congruent. In line 3, we proved a pair of sides congruent. And in line 4, we proved a pair of lines congruent. So don't worry about the order, okay, in which it lists in the actual proof. Go to your picture and notice that it's side, angle, side, congruent to side, angle, side. So we have side, angle, side. Right, in line 5, go ahead and name those two triangles. And I'm going to name them triangle MLN. And it's congruent to triangle ONL. I'm just going to move that triangle down. Okay. And as I mentioned, they are congruent by side, angle, side. Now once we have proved those triangles congruent, then we can take away other information. We get other information out of it, which is what we're trying to prove, that angle O is congruent to angle M. And notice in our little statements here about those congruent triangles, angle M comes first and angle O comes first. So that would be enough for us to say that they're congruent because they are corresponding parts of congruent triangles, so they're congruent. Again, corresponding parts of congruent triangles are congruent. And that's why we write CPCTC for short. All right, excuse me, let's take a look at two more. All right, our second proof is going to be one of the longest that we do this year. Okay, so we're going to take it step by step, one piece of given information at a time. And notice what we're trying to prove here is that triangle ACB is isosceles. And sometimes it makes sense to work backwards. We'll know that triangle ACB is isosceles if we can prove two sides congruent. All right, and my idea is that we want to prove side AC congruent to side BC. So sometimes in a problem, it helps if you try to work backwards from the answer, if you happen to know the answer. So that's a really good strategy to take with writing proofs. Okay, first, line segment CD is perpendicular to AB is given to us. Okay, so again, that symbol right there is for perpendicular lines, and perpendicular lines form 90-degree angles, or right angles. So in line 2, we're going to identify angle CDA and angle CDB as right angles. And when you go to write your statement in given, how we know that is by definition of perpendicular lines. You can use that symbol for perpendicular. All right, knowing that those two angles are right angles, we can say that angle CDA is congruent to angle CDB. I'm going to switch that. Looks a little like a B. So CDB. All right, that's a pair of angles congruent, and they're congruent because all right angles are congruent. Okay, that's all we can do with that piece of given information, but it did give us a pair of congruent angles. All right, next you're going to go on to your other given information, and that is that D is the midpoint of line segment AB. So if D is the midpoint, what it's doing is it's dividing the segment into two congruent parts. Okay, let's get that given information into the proof. So if you want to go ahead and write given for your fourth reason, go for it. And we have D is the midpoint of line segment AB. Okay, our takeaway from that is to use that word midpoint. A midpoint divides a segment into two congruent segments. So we have line segment AD congruent to line segment BD. And what we're going to do for the reason is say it's definition of midpoint. You see how that works? The line before it mentions a midpoint, and now we're using the definition of midpoint. Okay, that gives us a pair of sides that are congruent. Okay, so we've got a pair of angles, we've got a pair of sides. We're out of given information. Don't worry, we have something in our picture that's shared. So the two triangles share that segment, CD, so mark it congruent to itself, and we're going to get that into line 6. Line segment CD is congruent to line segment CD by the reflexive property. Alright, that's another pair of sides proved to be congruent. Again, don't worry about the order in which these things appear in your proof. Look at your picture and notice that it's side, angle, side. Side, angle, side. So SAS is going to allow us to say that those two triangles are congruent. So it'll be triangle CDA congruent to triangle CDB by side, angle, side. Right, believe it or not, we're almost there in our proof. Remember, we're trying to prove the triangle is isosceles, so we wanted to prove AC congruent to BC. So check it out. AC, last letter, first letter of the first triangle, and BC is last letter, first letter of the second triangle. So in step 8, we can say AC is congruent to BC by our new thing, CPCTC. They are corresponding parts of these congruent triangles, so they're congruent. Knock yourself out and mark those two congruent, and then we get to say triangle ACB is isosceles by definition. It's okay to abbreviate the word definition. You saw me do it up here too. Definition of an isosceles triangle. And that's it for that one. Alright, for this last one, it's our try it question. So ideally you would pause the video for a few minutes and try this proof on your own, and then come back and check it. Okay, so maybe try that. Alright, so here's your solution so you can kind of check your work. These two pieces of given information are just like short, quick facts, so we're going to put them together in line 1. So go ahead and say AE is congruent to DE, and say that DE is congruent to CE, because those two are given to us. And do me a huge favor. If you're not in the habit of marking your picture, mark it, because it's important. AE and BE are those two segments, and I'm going to not only mark it with a tick mark, I'm going to highlight it, because this one is a little bit different. It's not really drawn to scale, okay? DE is this line segment, and we're told that it's congruent to CE. Again, I know they don't appear to be exactly the same, and let's just assume that that's the intention of the writer of this proof. Okay, we are trying to prove angle D congruent to angle C, so we want to prove the triangle's congruent first. And then use CPCTC, okay? So this gives us one pair of sides, this gives us another pair of sides, and hopefully you can jump right in here and mark these vertical angles congruent. So that's what we're going to do on line 2. We're going to get a pair of congruent angles by saying angle AED is congruent to angle BEC. And again, that's going to be vertical angles are congruent. Okay, don't worry about the order of the things in your actual proof. Go to your picture and notice that it's side, angle, side. So in step 3, go ahead and say triangle AED is congruent to triangle BEC. So notice that change in symbol from angle to triangle. And these two triangles are congruent by side angle side. Now the takeaway, we want to prove that angle D is congruent to angle C, so check it out. Here's angle D, here's angle C. Ask yourself, are they in the same position in the names of those two triangles? The answer is yes, they are. So we're going to say in line 4, angle D congruent to angle C. And how they're congruent is that they're corresponding parts of congruent triangles. So they're congruent. CPCTC. All right, that's it. Good luck with practice number 6. As always, reach out to me if you have questions or you need some help with it.